Stop everything you're doing right now, because what you're about to hear is going to completely change the way you think about life on Earth, extinction, and honestly, our own future. 66 million years ago, something so catastrophic happened that it reset the entire biological clock of this planet. And the terrifying part? Scientists believe it could happen again. Here's what blew my mind. The asteroid that killed the dinosaurs wasn't just big. It was approximately 10 to 15 kilometers wide, roughly the size of Mount Everest, and it was traveling at an estimated speed of 20 kilometers per second when it slammed into what is now the Yucatan Peninsula in Mexico. The impact site, known today as the Chicxulub crater, stretches over 180 kilometers in diameter and is buried beneath the Gulf of Mexico and the Mexican coastline. That single collision released energy estimated to be 2 million times more powerful than the largest nuclear bomb ever detonated by humans. Let that number sink in for a second. But here's where it gets controversial, and most people get this completely wrong. The asteroid did not directly kill every dinosaur on day one. The real killer was what came after. Within seconds of impact, a fireball of superheated gas expanded outward at thousands of kilometers per hour, incinerating everything within hundreds of kilometers instantly. Then came the tsunamis. Some researchers estimate they reached heights of over 1.5 kilometers in certain coastal areas. The ground shook with earthquakes estimated at magnitude 11 or higher, stronger than anything we have ever recorded in human history. Now here is the part most documentaries skip over. The dust, ash, and sulfur ejected into the atmosphere from the impact blocked sunlight globally for an estimated 1 to 2 years. Photosynthesis essentially stopped. Plants died. Herbivores starved. Carnivores followed. The food chain collapsed from the bottom up. Scientists studying rock samples from the Chicxulub crater found evidence of enormous quantities of sulfur-rich rocks called anhydrite, and when those vaporized on impact, they released billions of tons of sulfur dioxide into the atmosphere, creating a global cooling effect that lasted years, possibly even decades. Temperatures plummeted by an estimated 10 to 15 degrees Celsius globally. This wasn't just a bad season. This was an extinction-level collapse of Earth's entire ecosystem. The geological evidence for this event is preserved in a thin layer of rock found all around the world called the KPG boundary, formerly known as the KT boundary. This layer, which marks the transition between the Cretaceous and Paleogene periods, is enriched with iridium, an element extremely rare on Earth but commonly found in asteroids. Physicist Luis Alvarez and his geologist son Walter Alvarez first identified this iridium anomaly in 1980, and it was this discovery that revolutionized our understanding of mass extinctions. Their hypothesis was controversial, even ridiculed at first. Today, it is supported by over 40 years of global scientific research across more than 350 sites on 6 continents. And here is something that most people find deeply unsettling. Not all dinosaurs went extinct. Birds are, in fact, living dinosaurs. Avian dinosaurs survived the catastrophe, likely because of their smaller body size, their ability to eat seeds that survived underground, and their capacity to fly to less affected regions. The non-avian dinosaurs, the massive Tyrannosaurus rex, the Triceratops, the Brachiosaurus, they were simply too large, too dependent on lush vegetation, and too slow to adapt to the sudden environmental collapse. Over 75% of all species on Earth went extinct during this period, making it the 5th mass extinction event in the history of our planet. But wait, before the asteroid even arrived, Earth was already under stress. The Deccan Traps, a massive volcanic region in what is now India, had been erupting for hundreds of thousands of years before the impact, releasing enormous volumes of carbon dioxide and sulfur dioxide into the atmosphere. Some scientists argue that dinosaurs were already struggling before the asteroid struck. This is the controversy that still divides the paleontology community today. Was the asteroid the sole killer, or was it the final blow to a world already weakened? The latest research, including a 2020 study published in the journal Science, suggests the asteroid was indeed the primary driver of the mass extinction, with the volcanic activity playing a secondary role. Here is the part that should genuinely concern you. NASA's Planetary Defense Coordination Office currently tracks over 2,300 potentially hazardous asteroids in our solar system. While no confirmed impact threatens Earth in the next 100 years, the risk is real and permanent. In 2022, NASA successfully tested its DART mission, deliberately crashing a spacecraft into an asteroid called Dimorphos to alter its orbit. It worked. For the first time in history, humanity actually moved a celestial body. We are the first species in Earth's known history to have the capability to defend against an extinction-level impact. The dinosaurs had no warning, no science, and no chance. We have all three. The real question is whether we will take this threat seriously enough before it becomes urgent. Every time you look up at the night sky, you are looking at the same universe that ended the age of the dinosaurs and launched the age of mammals, which eventually led to us sitting here, having this conversation. Think about that. If you found this as mind-blowing as I did, follow this page right now because we go this deep on science, history, and the events that shaped our world every single week. You do not want to miss what we are covering next. Now tell me in the comments, if scientists discovered an asteroid heading toward Earth tomorrow, do you think humanity would actually be able to stop it in time?